bridge. How are you doing? It's week 6. It is the first assignment. It is 6.1. I want to congratulate you because I think we've done a lot with logarithms through this online learning, and we've done a lot before the closure. We did a lot with exponentials. So I think, you know what? I think it's time to move on. Let's look at the quadratic section of the Bridge to College unit. All right, so now we're technically in unit 7, and we're gonna look at some quadratics. Maybe you've heard of them before. First, I got a bridge of the day for you. Any guesses? It is the bridge in Troutdale, Oregon over the Sandy River. Alrighty, very pretty. I like that green. So we're gonna look at quadratics real quick. Quadratic equation. You've heard this before. It's an equation involving the second and no higher power of a variable. All right. So a variable, we'll just use x, and x has the second and no higher power. So the first degree, or it's raised to the first power, no. The second power, yes, that's a quadratic. What if I raise it to the third power? Nope, that's not a quadratic, right? The second and no higher. So here is my quadratic equation. I could say y equals x squared. Let's give some more examples. Maybe we do y equals 3 times x squared. It's still a quadratic. Even though I'm multiplying by 3, I have a variable and it's raised to the second power and no higher. What about y equals negative x squared? Yep, well, this is really just like negative 1 times x squared to give us that negative x squared. It's still considered a quadratic equation. We have that variable. It's raised to the power of 2. What about y equals x squared plus 3? Yes, indeed. These are things you've probably seen before. 3x minus 4, right? That's still a quadratic equation. Again, even though I have that x there, this x right here, my highest power is still 2 and no power above that, all right? So these are all examples of quadratic equations. We're going to start very basic and just look at this one real quick to just start graphing. So, again, we're looking at y equals x squared. Here's my x. I'm just going to make a table of values so we see what the general shape of it is. I know you're probably used to this. So if I plug in some x values, what is my y value here? So let's just put in negative 4, right? If I put negative 4 into this function, it's really negative 4 squared. And here, since the negative is on the inside, right, I'm really doing negative 4 times negative 4, and then negative times a negative. It's going to give you a positive 16, all right? Negative 4 squared and negative 4 squared are not the same thing, all right? This says negative 4 times negative 4, and this says negative 4 times 4, which would give you a negative 16, whereas here you get a positive 16. So I just want to point out that difference, all right? So the same thing with this negative 3. That's that negative on the inside. It's really 3 times, or excuse me, it's negative 3 times negative 3, right? And that's just going to give you a positive 9, all right? Negative 2 squared, negative 2 times negative 2. Again, our exponents are repeated multiplication, so that gives you a positive 4. Negative 1 squared, negative 1 times negative 1, just positive 1. 0 squared is obviously just 0. And then I could do the same thing going with our positive numbers, but that's just a lot easier, right? 1 squared is just 1. 2, if I plug in x equals 2, 2 squared is 4. Let's just do, I'm going to finish this off real quick. 3 squared is 9. And then, oops, there's my x value. 4 squared is 16. So on my little graph here, if I graphed all of these equations, so the first one I'm going to go out to negative 4 and then all the way up to positive 16. There we go. And then negative 3 and a positive 9. And what's the next one? Negative 2 and a positive 4. Negative 1, 1, 0, 0. And then we see that it's kind of like reflected on the other side of my y-axis. Very cool. So if I connect all those dots, that's going to give me, that's going to give me this graph that looks something similar to this. Okay. So probably a shape that you could all recognize, you've all heard before, these quadratics. We've also heard them called parabolas. All right. So let's do another one, but what if we did graphing? What if we did like y equals negative x squared? Okay. If I do negative x squared, let's do this real quick. Let's just plug in a couple values. So if I did negative 2, that means I have that negative on the outside of negative 2 squared. So it's negative 2 squared. All right, and that gets me negative, well, negative 2 squared is a positive 4, right? And that positive 4, but again, there's that still negative on the outside, so that's going to make it a negative 4, right? So if I graph that point, negative 2, negative 4, that's going to be down here. Let's just do another one. If I did 1, right, and it's going to be a negative 1 squared. Again, that's just going to be negative 1, which is just negative 1. So it's looking like these are all kind of reflected now. So it's like a reflection across the x-axis of my original parabola. Let's just plug in a 3, right? So if I plug in 3, that's going to give me negative 3 squared, which is negative 9, which again is just negative 9 here. So again, if I sketch this one out now, I see that this is a reflection. So up here is x squared, here is negative x squared, all right? They're just reflected across the y-axis, or excuse me, the x-axis. And if you want to think about it, this right here, we could say is concave up, because again, this thing is pointing, it's pointing up, right? So this is technically concave up. Let's just add some vocabulary for here. And then this one we would describe as concave down. All right, it's pointing down. Everything's pointing down there. So we've graphed some two nice I almost said exponential. Oh, we've been in exponential chapter so long. We've graphed two nice parabolas. Let's just take a look at where we might actually find some parabolas in the real world, because we're going to be studying this as we start finishing off our online learning here. Please tell me you know this game. You've heard this game probably. It's not sponsored by Angry Birds. It's not my favorite game, but it does involve some quadratics, some parabolas that you're used to, right? You see, again, this general shape here, which is quite nice, all right? That would be a concave down parabola, a concave down quadratic. This is like a quadratic graph, all right? Again, with this one, right? You see that these are all, I mean, we could just, even just from like the start, all these little points right here, you could predict this entire graph, okay? And again, this would be considered a concave down graph. I actually have Angry Birds pulled up. I had to play one level. Oh my, this is okay. I just want to. Oh my goodness. Hey, there you go. Okay, check it out. Give me a bird. Okay. Oh. Right, you could make your quadratic high. It would have a high, what we would call vertex, like a maximum point, or you can make this kind of more shallow. Again, we see in these Angry Bird things that they're all concave down, right? Oh, look, there's a tiny little parabola. Okay, this was not as exciting as I was thinking it was going to be. Tap. Wow, that's, okay, we're going back. This was really fun. This was great. Okay, anyway, there is going to be a little project that I wanted to do with you guys in class, but unfortunately, again, we are no longer in class. So I'm going to show you what it is, and if you want to build it at home, you totally can. I would highly suggest it. And if you do build this little project at home, you know, post a picture to the assignment. I would love to see some gummy bear action. All right, there is an assignment on Google Classroom, and it's going to ask you, like, is this an example of a quadratic graph or not? And then I'm going to ask you, what are a couple examples where you might see some quadratics in real life? I've already given you two examples, right? This Angry Birds, I mean, that's a real life, it's a program, and it involves quadratics. You could model this bird's path with this quadratic here. And in a second, you'll see a second example of using quadratics in real life with my gummy bear cannon. All right. Have a great day, guys, and I will see you later. Go team! So this was what we were going to build if we had a fun day in class. We were going to make a little gummy bear launcher and explore some quadratics and the shape of quadratics with it. But, of course, we're in the school closure, so we can't really do that. But, again, if you would like to build one of these at home, I would love to see your little creation. Maybe you found a better way to launch some gummy bears. Send me a picture. I would be ecstatic. I would be on the top of the moon. Please do it. I would love it. I just two popsicle sticks, and I taped them so that there's a Sharpie or a pen or something round or something so it makes like a little fulcrum that you can then launch. So I'm going to take this little guy. Oh no, help me. See, this is the funnest lesson you're getting. All right, ready? So he's going to get on there. I haven't done this yet, so ready? Okay. Well, I'm gonna do it a little softer. It hit my ceiling and then it went down. So let me try a little softer. Oh, that was cute. Did it even register? I don't know. I'll do some more. Anyway, we will explore some quadratics with this and have a good day. Nom nom nom.